Hi guys, Mr. Eskew here. Finally guys, we're getting to our end of our unit on nomenclature, and up to this point in time you have been given the formula and you've been writing the name of that formula. Now we're just simply going to go the other way, and quite frankly it's easier to go the other way. So this is relatively simple. So we're going to be writing formulas from the names. Alright, get out those handy dandy nomenclature notebooks and 2 new pages, left side. Of course, put in your title here, writing formulas from the names. And our first bullet is going to be, for type 3 compounds, use the prefixes to determine the subscripts. And I'll give some examples of that in just a little bit, but quite frankly, this is so easy to do, you won't have any problems at all. Okay, and now for all the other different types of nomenclature, other than the type 3, and we're talking type 1, type 2, polyatomic ions, acids, this is the procedure. First, you determine the ions that are present. Then you record or determine the charges of the cation and the anion. And then you're going to use what I'm going to call the crisscross method to get subscripts for your formulas. Now, if you can reduce those subscripts, you need to do that. And I'll show you an example of that as we go. Alright guys, we're going to do some examples now. Of course, in your handy dandy nomenclature notebook, you're going to be on the right side, so go ahead and put examples. We're going to have 3, so you can space yourself out correctly on your page. We're going to have 3 examples, and we're going to start out with this one. If you were given the name dinitrogen pentachloride. Clearly, I hope you recognize that as a type 3 compound. So we go over to the left and we see what we're going to do is basically we're going to use our Greek prefixes to determine our subscripts. Now, di, of course, means 2, so we're going to have 2 nitrogens. And penta is going to be 5, and the symbol for chlorine is Cl, and we're just simply going to put a 5. Guys, these are really about the easiest there is. I love type 3s. You just look at the, if we've learned our prefixes, it makes them really simple. All right, guys, here's our second example. We're going to go with copper. Let me get my pen going here. My fault. We're going to go with copper 2, there's our Roman numeral, sulfate. Now, clearly this screams at you as a type 2, not because it's a Roman numeral 2, but simply because you have a Roman numeral. So we have to work this out. Now, immediately, as soon as you see that Roman numeral, you know the charge on your copper. It's a +2. It comes right from there. And then, of course, we've memorized sulfate, haven't we, guys? Yeah. All right, sulfate is SO4, and it has a charge of a -2. Now notice what I've done here. I've written my cation, and I've written my anion, and I've determined the charges on them. Okay, and now we're going to use, and this is new to you, what is called the crisscross method for determining your subscripts. Now watch what I do here. I'm going to crisscross the absolute values of the charges, and I'm going to put this one right here. And then I'm going to crisscross the absolute value of the charge, and I'm going to put it right here. Now you can see that I've got two coppers and I've got 2 sulfates. But if you notice in the notes, in the parenthesis over there, it says reduce if possible. And what I'm talking about is reduce those subscripts if possible. So what you're going to do right there is these 2's reduce to 2 1s. Let me change my color here. This becomes 1 copper and 1 sulfate. So when you write this formula, the formula becomes Cu, and there's only one of them, SO4, and I only have 1 SO4. So this becomes, sorry guys, this becomes the formula for copper 2 sulfate. All right, let's go to our third example. Our third example is going to be calcium hydroxide. Okay, figure out your anions, your cations and your anions, and we get calcium. And we know calcium has a fixed charge. You look on your periodic table, it's in group 2. And hydroxide, which we've memorized, is OH, and we know that its charge is a -1. So we know our cations, we know our anions, and we know our charges. Now we're going to apply the crisscross method. I'm going to take the absolute value of the charges, and I'm going to need 1 calcium for every 2 hydroxides. And then my formula becomes calcium, I only need 1, because right here, there's only 1. And then I'm going to have hydroxide. But if you notice, I need 2 hydroxides. And the way you do that, the way you write that formula is, since you need 2 hydroxides, you've got to put it in parentheses. And then you put a 2 on the outside. So what we're saying is, I need 2 hydroxides. And this is the formula for calcium hydroxide. All right, guys, we're going to do some practice problems now.